Good afternoon, everybody. Welcome to my channel, Data-Driven Decisions. We haven't talked much about data modeling, which is probably the most difficult concept to grasp in data and analytics. And truthfully, everyone has a different philosophy on what they can do, what they believe in. Um, it makes it very difficult, to work with other business intelligence engineers um, when you're not controlling the schema of the data model. If it's somebody else's, uh, for me, it's hard to grasp, a data model that has flow and connections that um, I'm not well aware of. I don't yet know how to use it. For me, I always try to do star schema. That's kind of how I look at things. Dimensional modeling is a nice uh, field concept that explains, uh, you know, the star schema, the, basically breaking any table into either a dimension table or a fact table, and knowing how to join tables. And in my personal finance ecosystem, I have a large amount of tables, about 25, and I just spent about a half hour just organizing the data model so that it looks the way I want it. And this is like an expanded star schema model. It's got many fact tables, columnar tables. So some of like the main table is monthly finances. That's the main fact table. That's just unique by month, but it's got a field for tons and tons, about 250, 275 different fields of metrics. And then there's columnar tables, which just take all of those fields and turn it into one column. And, it's differentiated by the attribute value rather than by the field now. And it's a very, very long table and not very wide. And, those are also fact tables in and of themselves. And they're much more granular than, the very wide fact tables. But nonetheless, um, it's a weird data model that I have in Power BI. Let me share it. So here's the data model in Power BI, and it's got a lot of tables, about 30 of them, and it's it's got a lot of dim tables, a lot of long fact tables, and a lot of wide fact tables, and mostly, it's a lot of the same data. The big fact tables are monthly finances, mint transactions. That's the transaction table that's coming out of personal capital. And then monthly budget is also a nice fact table that doesn't have many connections to it, just to the month table. Um, I have some new validation tables. I have some very large monthly finance history tables, and then I have history columnar, which is going to be my largest table in this data model. Right now, it's up to like 200,000 rows, and it's only got about 5 or 6, runs in it. By the time in like a year, it's going to get up to, probably tens of millions of rows, and that's still pretty tiny. But I'm happy that you know, this is just my personal finances, and it's not big data at all. The data's tiny, and I'm glad I was able to build a big table in this ecosystem, one that makes sense, one that's useful. Um, you know, just uh, just so that I'm working with a new concept. With big tables, the game changes a lot in that you need to be efficient with your code and your logic. Uh, you need to figure out whether you really want to do direct query or import mode. Um, you got to understand that, queries are in the costs of cents, and, with hundreds of queries and you're talking dollars. So when you're dealing with big data, there's a cost to every query. So when you're dealing with small data, none of those rules matter. Everything you do, no matter how many tables you create, no matter how many intermediate tables, no matter how many queries you run, you're just talking cents, in total. So it doesn't matter. But with big data, when you're working with a billion or more rows, you really got to be cognizant about efficiency. But, this is the data model, and, um, you know, the tables are in different schemas, but most of the same tables. If I show you, so like monthly finance, that's the main fact table. That's really the root of the project. This is not too many rows, but many, many fields. And then if we go to its reshape, the columnar table, it's not too many fields, doesn't even have a scroll, but it's got a ton of rows. It's got 43,000 rows. And the monthly history columnar table, this is my biggest table. It's got 263,000 rows already. So this table is going to get really big, and that's fine. It's not going to get too big for me to have to worry about costs or things, but it's going to be big enough that you know, the queries are going to take a little bit longer, and it's now like a medium data project instead of small data. Um, the other important tables are like monthly budget. This is a columnar table too. It's got actual goal. It's got the five basic metrics that I want for my budget. And then there's a lot of uh, like the account table is an additive account. It just looks at all my accounts, and this is you know um, a fact table in itself that connects to the main fact table, monthly finances. So it's a fact table connected to a fact table. Um, that's okay because this is columnar. Um, if I go over to the data model, like the account table right here, just connects to the monthly finance table. And since it's one to many, if you filter this table or any of the dim tables that are connected to this, it'll also filter this table. So, the stream of filters go from the one to the many side. So when you think of the stream of logic, it really has an order. Um, the dim tables are always one to many in the relationship to the fact table, and that makes it, its filters are able to transpire into the fact table and filter that. Um, so the filters flow from the one to the many side, and that's very important to understand. Um, anyway, I also added a little bit to this dashboard. I added some statistical measures. Um, at some point, I want to apply statistics into this ecosystem, and it's a process. It's a journey in analytics. It goes from descriptive to it goes from exploratory to descriptive to predictive to prescriptive. And right now uh, we're getting to the second stage, and I want to get to the point where we're using statistical analysis to forecast the future, to find out, answer questions, and um, make this prescriptive. But this table right here, which has um, every single metric from the monthly finance table in a columnar format. Um, so like cash flow, this is one of the most important metrics, just to understand how much money you have left over between your take home and your spend. And this is a nice distribution of the cash flow. So most of the time I'm making between 100 and 200, 1,000 and 2,000 in cash flow, but sometimes I'm way over, sometimes I'm way under. It's a very volatile metric. And then there's something like, spend total. For the most part, I'm usually spending 4 and 5 grand. Not anymore. I'm spending more like between 7 and 9 grand lately. And this box and whisper plot is the other nice way to show distribution. Histogram shows distribution. It just really takes out the order of the months and just kind of creates buckets. This x-axis is really just a span of buckets. It's the monthly spend in this scenario. The most I've spent was between 22 and 23,000, but most commonly I'm spending between 4 and 5,000. But as of late, it's more like 7 to 9,000. So these are buckets. Each bin is just a range of values, and then the y-axis is the number of times a month falls into that bucket. So most commonly, most months have spend between 4 and 5,000. But spend is something that grows over time. Definitely as I make more money, I spend more money. Inflation is certainly taking a hit on everything, so everything's more expensive. Um, if we net worth change, most commonly it goes from 0 to 1,000. That's the most common bucket. Um, looking at this box and whisker plot, it shows the median, which is the line between the two blues, the mean, which is that red circle, the 75th percentile, the 25th percentile, this um, the whisker is 1.5 times the interquartile region, so 1.5 times the size of these blue bars, and anything outside of that is kind of what you call an outlier. So in some months, one month I made 16,000 in net worth change, and one month 17. Those were outliers. And then on the narrow side, some months I lost 10,000, 9,000. Those are outliers in themselves. The mean is 2,515. So most months, that's how much I'm making. That's awesome. The median value is 2,143. The standard deviation, which is like the measure of the variance or the spread of the data, it's tough to grasp. It's a kind of a difficult equation, but one standard deviation is 4,664. So if the way it works is if you take the mean value and add one standard deviation, that means that if you do that both on the plus and the minus side, 67% of the population is going to fall into that bin of width. If you go out 2 standard deviations, 95% of the population is going to fall into those buckets. And then 3 standard deviations is like, I don't know, it's high 90s. It's almost all of it. It's like 99.5% fall into that. So that's kind of how standard deviation works. It's basically the probability of um, the normal distribution. This is somewhat of a normal distribution, bell curve. It certainly has that kind of shape. And when I say 67% fall within 1 standard deviation, if we do the math, 2515 plus 4,600, that's about 7,100. So from like right here, and then on the low side, like negative 2,000 right here, you see that 67% for the most part fall into that bucket. And if you got 2 standard deviations, it's going to be like 95%. If you go out 3%, 3 standard deviations, I think it's 99.7, and you're capturing them all. So that's really, when it comes to statistics, these are the kind of things you like to see, distribution and variance and standard deviation of your numbers, and that kind of puts you in a position to then do your statistical analysis. So these are called exploratory metrics to measure distribution. And my degrees are in statistics. I definitely don't use much statistics on my job as a business intelligence engineer, but this is my project. I get to have it forever, so I get to just grow and grow upon it. And yes, I'm getting to the point where I want to apply statistics to this. So I'm just going to read books and start thinking about it. Reread my notebooks from college, and try to apply some statistical analysis in this ecosystem. Hello, welcome back. I added another row of visual to this dashboard, and I think it's really cool. It's the it's just a column chart of the metric, and in our case right now we're looking at the net investment gain moving average, so yearly moving average. So um, it's at a yearly level. So back in 2021, 2022, I was making a net worth gain of 40 grand. I was doing really well then, and you see this line right here. What it is the yearly average. Um, I wish it didn't have the connecting lines, but I don't know how to do that. But it really just kind of shows, uh, you know, what the yearly average was, and then you see all these horizontal lines. That's all the percentiles, the median, the mean, the 20, the upper quartile, the 95th, 90, and the 5th percentile, all the way to the min and the max, just to see how the data points are measuring up to percentiles. In 2023, that was a rough year. That was when I bought my house, and I was really losing net worth. But now in 2024, we're uh, we're on pace to um, make 2 grand in the year. Not good, but at least it's positive, and I have high hopes for the future of it, looking really good. Um, on this next page, um, I did calculate the z-scores of every single value. The z-score is the data point minus its mean divided by its standard deviation. It's typically a number between -3 and 3. It's how many standard deviations away that number is from the mean. Um, when you do that, now it's a standardized number. If I go to BigQuery, I'll show you it. The equations were pretty simple. It's just a query, just aggregating for every metric and then calculating all these summary statistics, the average, the standard deviation, the min, the max, and then to get percentiles, it's this function, the approx quartiles function. Set it always at 100 and then just do this offset to get the exact percentile. So I got the median, quartile 1, quartile 3, and then a bunch of percentiles. And then that kind of just gets merged into the main table. So every row is the same for the same metric name for these values. These are all summary statistics. So far, we've really been on a data journey where we've been enriching and enriching and enriching data to various levels. And I've taken it to a whole new level, a very large table. The monthly finances columnar table, which is also a very long table. I massively increased that size by cross-joining the same table to it so that I have two metrics side by side that can be compared against each other. And this really allows for some great correlation analysis, very easy to do. Let me share my screen and I'll show you. So on this page, this dashboard, it's just got two filters. You got your choice of, for metric number 1 and metric number 2, which two metrics do you want to compare? So in this scenario, we're comparing total spend versus net worth change. So how much does total spend predict net worth change? And here's a side-by-side bar chart showing the two metrics together. And here's a scatter plot showing the two metrics and how they correlate. Is there a line there or no? Well, the correlation coefficient answers that question. And no, there is no correlation, surprisingly, between the amount of money I spend in the month and my net worth change. That is very weird. I would expect there's certainly to be a high negative correlation between my spend and my net worth change. The more I spend, the lower my net worth is. But weirdly enough, there is no correlation. So this is just a really cool dashboard. I'm really focusing on net worth change as my why. That's really what I'm trying to predict. I'm always trying to just increase my net worth. And I can look at every single metric to see the correlation. Something very high is my net take home compared to my net worth change. The months where I take in a lot of money, my net worth changes a lot. And you can see in this scatter plot, there is a very high correlation between my net take home and my net worth change, positive 57%. So that means that 57% of the variability in net take home explains positively the net worth change. So this is a number that goes from negative 100% to 100%. 100% means perfect positive correlation. Negative 100% means perfect negative correlation. Inverse, you would see a negative sloping line. And 0 is no correlation. And 50%, 57%, that's very good. That's very high correlation. We can look at the spend categories like groceries. That's somewhere I'm spending a lot. And weirdly enough, it's a positive correlation. So the more I spend on groceries, the higher my net worth increases. Eating out, negative correlation. I need to stop eating out. The more I eat out, the lower my net worth is. Um, My mortgage. That's kind of weird. That's a constant. Uh, all right, I got to spend on dog. There's a positive correlation. The more I spend on dog, the higher my net worth. What about books? Zero correlation. Health. Zero. Clothes. Very negative. Don't spend on clothes. Dating. Positive. Wow. Tithing. Positive. Home. Very negative. Electronics. Negative. The more I spend on essentials, the more my net worth increases, weirdly enough. And the less I spend on non-essentials, the higher my net worth increases. So focus on the essentials and get rid of the non-essentials. Oddly enough, total spend, not much of a correlation. Net food, the more I eat, the more my net worth increases. Now this is a lot because over time, the more money I made, the more money I spend, and the net worth changes at higher rates because I have more money in the stakes. So there's just a time correlation that I might want to figure out how to adjust out of it so that it's like a true timeless correlation. Take out the time variation. Cash flow, very positive. Cash flow is what I try to really control. I can't control my net worth change. I can control my cash flow, and there's a very positive correlation between a good high positive cash flow and positive net worth change. It's a key ingredient to it. Explains 57% of it. Taken to another page, just focusing on net worth change. I want to see what affects it. So I got every correlation right here, and I can sort it. Let's see what has terribly negative. Rent, very negative. Time correlation, I no longer have rent, so that's why. Total debt, spending on other is very bad. Just spending on the credit card is bad. Spending on the Best Buy card is bad. Spending on this card, so it's almost like these are spending on clothes is bad. What's really good? Most of these I won't even explain because so net take home, very high. The investment interest, very high. Those are two ingredients of net worth change. Cash flow, very high. The other ingredient, key ingredient. These two are part of it. The 401k growth is mostly made up of what the net worth change is. This is the account personal IRA return. That's weird. Negligent small account. Vanguard personal. Vanguard personal. So that no longer really has much money in it. Weird that that's so highly correlated. the pre-tax takeout. So this is like saying probably the more I take out in taxes, that's a lot because bonuses are high tax takeout months, and those are high net worth change months. So there's a correlation, but maybe also because the more I put in the 401k, which is also part of this, the higher my net worth changes, and that makes sense. Total earnings, yeah. The net pay plus 401k, yeah. Yearly net pay. Let's look at the weird one. So Uber income really increases my net worth. I got to do that. Of course, the bonus. This is really cool. I just really get to see how things are related to each other, and both these dashboards are helping me do that. This one lets me look at all of them, and this one just lets me focus on just two at a time, two a comparison. How did I build this in BigQuery? Uh, I built this in BigQuery. I made a really large table right here I call this a cross join. It's a left join, but it's just missing the metric dimension. So every metric is going against every metric, and that's really extrapolating the table, making it very big, 12 million rows. This is query calculates the correlation coefficient and makes these compare fields. And then I just merge those two tables together in this query, and that's it. And yeah, it's a very large table, over 12 million rows. So now it's getting into big data realm, but there's no finer way to do something like this, a dashboard like this, where it's just comparing. I guess you could possibly do a parameter to try to get something like this, but what I chose to do was just really extrapolate the table, make there a metric for every metric in a comparison that has its own rows of data, each comparison, and that just allows for a quick comparison tool such as this. Yeah, there's not an easier way to do this. This is all part of the data investigation stage, to understand your data, to explore it, to understand the patterns, to find them. And just putting the data in different shapes allows for different visualizations to be made. So yeah, this one, just to focus on correlation, one metric versus another. I'm honing in on that just to find out what's really predicting what, and I'll just keep chipping away at this. All right, so I got this dashboard finalized. I think it looks pretty good with what I want. So in this line chart, it was a bar chart. I changed it to a line chart, and I'm measuring z-scores. So they're always going to be standardized values that are of the same magnitude no matter what I change. And then I found this scatter plot with a regression on it from the store in Power BI, and this is awesome. So, a scatter plot comparing the two numbers, and then a linear regression line showing what the correlation is. It's obviously a positive. The correlation coefficient is 57.13%, and you see that also measured um, in this plot, and it's the same. So that's cool. This is measured in BigQuery. This is measured in Power BI. And here's that fit line. So it basically means that for every dollar I put into positive cash flow, my net worth increases by 40 cents. So so it's a big part of net worth change is having positive um, cash flow. So yeah, pretty cool. I hope you like it. Have a good one.